Class. In this class, we are going to study about pure tone audiometry, right? The question comes in, why do we need to study about pure tone audiometry? We as audiologists, what is our role? Our role is to know about hearing and hearing disorders. To know about hearing and hearing disorders, we should be in a position to measure out the hearing. Only then we will say that this is not as per the measurement, so there is a disorder, correct? To measure hearing, what is the type of stimuli that needs to be measured? Tell me. It is sound. Sound is the stimuli which needs to be measured. So to measure sound or the stimuli which is auditory in nature, which are the parameters of sound? For example, if I am speaking like this and then I start speaking like this, there is a difference between both of the things. The first difference is in terms of intensity. The second difference would be if I start speaking like this and then I start speaking like this. There is a fundamental difference between both. That is in terms of the frequency of the sound. So second defining parameter is the frequency of the sound. The third would be if you give a continuous sound or if you give a sound which is in short breaks. It can be a ting sound or it can be a ting sound. It can be a tick 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 sound. So the third parameter is time. Time can be controlled, not a problem. But frequency and intensity, these are the two parameters which define how a particular sound is. So we take up these two parameters and we check our entire range of hearing. Correct? If we check our entire range of hearing in a unit known as pascals or in a unit known as hertz, the minimum frequency which we can hear is 20 hertz and the maximum is 20,000 hertz. So the difference between 20 hertz and 20,000 hertz is how much? 10,000 times. So the softest sound in terms of frequency which we hear is 10,000 times lesser than the maximum frequency which we can hear. So it's a wide range, 10,000. Similarly, if we check the intensity in which we hear, the minimum intensity of sound which we can hear in pascals is how much? 20 to 10 to the power minus 6 pascals. And the maximum intensity sound which we can hear is 20 pascals. So if you see these two, then the difference is 10 lakh times. So the minimum intensity which we hear and the maximum intensity which we hear is 10 lakh time difference. And the minimum frequency and the maximum frequency is 10,000 times. So if we test the entire range of frequency, will it be feasible? Not feasible. How many points you can keep testing? So we started seeing, as an audiologist, shall we test the full range? Time consuming, effortful, not needed on top of it. So we started seeing, why do we use our hearing? If our hearing is put to use appropriately, we are okay with hearing loss or no hearing loss. So using our hearing, if we see, then we use our hearing 95% of the time to hear speech and another 5% to hear music. So we thought, let us take in the speech frequency range. When we take the speech frequency range as the test range, we found out that in the frequency parameter, we see that our speech sounds are maximally between 125 Hz to 8 kHz. And in terms of intensity also, we found out the intensity and plotted it as minus 10 dB HL to 120 dB HL. The suffix is important here because for our convenience, we took 0 dB HL across these frequencies and fed an amount of sound into this for which maximum normal people would respond. So that's the threshold, which is the minimum sound which is there. So the amount of sound which would be there at 125 Hz would be different than 500 Hz, than 1 kHz. So 0 dB HL does not mean silence. So the frequency range which we are using, intensity range which we are using is purely on our convenience so that our hearing is found to be fit enough to hear speech sounds. Correct? So this is one basic fundamental of pure tone audiometry. I hope you understood this. Thanks. Thank you.